Now see this question. Consider a hemispherical furnace of diameter d is equal to 6 meter with a flat base. The dome of the furnace has an emissivity of 0.7 and the flat base is a black body. The base and the dome are maintained at uniform temperature of 300 Kelvin and 1200 Kelvin respectively. Under steady state condition, the rate of radiation heat transfer from the dome to the base is in kilowatt. And Stephens Boltzmann constant is given, that is 5.67 into 10 to the power minus 8 watt per meter square Kelvin to the power 4. Fine. So this is the dome, this is a hemispherical dome, this is a hemispherical furnace, and this is the flat base. So I am considering the flat base as a surface number 2, and this is a dome, and dome is a surface number 1. I am considering the dome as a surface number 1. So the dome emissivity is 0.7. So epsilon 1 is equal to 0.7 and temperature of the dome is 1200 Kelvin. For the base is a black body, so emissivity is equal to 1. So epsilon 2 is equal to 1 and the T2 is equal to 300 Kelvin, right? And this base is a surface number 2. Fine. So the net radiation heat exchange, in this case we can write net radiation heat exchange is A1 Fg12 sigma b T1 to the power 4 T1 to the power 4 minus T2 to the power 4. We can write in this way: A1 Fg12 sigma b T1 to the power 4 minus T to the power 4. And what is the Fg12? That Fg12 is interchange factor. Fg12 is interchange factor, right? And if you see this Fg12, this Fg12 is 1 upon 1 minus epsilon 1 by epsilon 1 plus 1 upon F12 plus 1 minus epsilon 2 by epsilon 2 into A1 by A2, right? Now F12 is nothing but the view factor or shape factor, right? View factor or shape factor, and we can calculate this F12 by using the reciprocity theorem, right? So from reciprocity theorem, from reciprocity theorem we can write A1 F12 is equal to A2 F21, right? A1 F12 is equal to A2 F21. Now see, what is the F21? That F21 is equal to 1. Why? Because F22, right? This is a flat surface. So for the flat surface, that F22 is 0. For the flat surface, F22 is 0. F22 is 0. And if you apply the shape factor algebra for the surface number 2, so we can write F22 plus F21 is equal to 1. So F22 is 0. So F21 is equal to 1. So simply we can write that F12 is equal to A2 by A1, right? F12 is equal to A2 by A1. And what is the A2? What is the A2? That A2 is, this is the pi r square. And what is the A1? That A1 is 2 pi r square. So pi r square is cancelled out. So F12 is equal to 1 by 2. Okay, now put here and see that epsilon 1 is equal to 1. So this term is 0. Epsilon 1 is equal to 1. So this term is 0, 0 plus. Now 1 upon F12. So this is 1 upon 1 by 2. So this is 2 plus. This is 1 minus epsilon 2 is 0.7 upon, this is 0.7 into that A1 by A2, right? So A2 by A1 is 1 by 2. So A1 by A2 is 2. So from here you can easily calculate the interchange factor Fg12, right? And this Fg12 I already calculated. So this Fg12 is 0.41176, right? This is the interchange factor Fg12. And once you know the Fg12, Now you can easily calculate the radiation heat exchange from the dome to the base, right? This is the A1 Fg12 sigma B T1 to the power 4 minus T to the power 4, right? So A1 is, this is 2 pi r square, right? 2 pi r square for the hemisphere surface area is 2 pi r square, and Fg12 we already calculate 0.41176, 0.41176 into sigma B is 5.67 into 10 to the power minus 8 into T1. That T1 is 1200 to the power 4 minus 300 to the power 4. That T2 is 300. So R is equal to, right? R is equal to the total, the base dia is 6 meter. So R is equal to 3 meter. R is equal to 3 meter. Now put the value of R here, and finally if you solve this, what you are getting? The final answer is, I already calculated na, 2726.935 kilowatt. So this is the radiation heat exchange from the dome to the base. This is the final answer.